In this one, let's take a deep dive into limit notation. So I'm going to explain in a great amount of detail. Okay? So how does it arise? What is the process that gives rise to it? You got to begin with that. Why would somebody create it? So think about a really fundamental object like a number line, right? Right here's a number line. Okay. And then let's say we have another number line this way. We'll call this y. The usual names, or you can call them Bob and Harry if you want. Just kidding. So x and y. Now, pick a number. Say a number on here. It doesn't matter. Somewhere pick a number and call it 2. Or whatever you want. It doesn't matter. Some number, okay? Above it, draw a graph. Say like this graph right here. Okay, so we have this graph. And now, what can happen in this kind of scenario? Let's think about this carefully. So, one thing that we can do is looking at the 2 on the horizontal axis, you can simply approach it either from the right or from the left. Those are really the two things you can do. It's true you could approach it from like above or from below, but our numbers are on the horizontal axis, so we're going to focus on that. That's where the numbers are located. So I'm going to approach from here, like this. I have to express this fact somehow. That imagine this is x, and x stands for different values to the right of 2, like 2.5 or 2.4, 2.3, 2.2, and so on. So x is assuming those different values. How do we express the fact that x basically is going towards 2 and is doing it from the right side? Through values one more time, like 2.5, 2.4, 2.3, and all the intermediate values. Well, we would say symbolically the following. X approaches, we use an arrow, so x is approaching 2, but we have the sense of direction because it's coming from the right side. So you would say here, put there a little positive symbol. So x is approaching 2 from the right side. Okay. Now, imagine right above this line, so let me use my, there you go, there's a point right here, okay? Right above the 2, there's a point. This describes what happens along the x-axis, right? This says x is approaching 2 from the right side, like this, from here, this way, okay? Then the question is, when that occurs, look what happens, right? When x is here, we are here. When x is here, we are here. When x is here, we are here, right? So the points on the graph, they're moving up the graph this way, towards this, you see? In that direction. Those are the points on the graph. What happens to the y-coordinates? Well, the y-coordinates, remember, come from the vertical axis. So as that occurs, look carefully, right? If x is here, then the y is where? The y is like about here, correct? When x is here, y is where? Y is about here. When x is here, y is where? Y is about here, correct? So as x gets closer to 2 from the right side, the points on the graph move this way, and the corresponding y-coordinates of those points, remember, a point after all is a specific kind of object, right? It's an x and a y. So we're looking at what's happening with that right there. So as x approaches 2 from the right side, points go this way, and the y-coordinates move up this way, in this direction, along the vertical axis. And this, lastly, as you get closer and closer, look what happens, right? Eventually you might reach this. So let's say this is some value. This is 2, so 1, this might be like a 0.8. It doesn't really matter the specific number. Let's say this is 0.8 right there, okay? So then how do you marry what's happening on the horizontal axis with what's happening on the vertical axis, that process, symbolically? Well, what can we do? We can write it as follows. We can say x is approaching 2 from the right side, and the values of y are going up to 0.8. They're kind of doing it from below towards 0.8. So we introduce this notation, LIM, which is short for limit. So the limit of y, right here, what is y? Y refers to the different values you get here as you approach, right, up to the 0.8. So the limit of y as x approaches 2 from the right side is 0.8. If you like, you can say the limit as x approaches 2 from the right side of y is 0.8. So in other words, when you look at this notation, Right? This describes very carefully, right, what's happening along the x-axis. And then this part of the notation, so to speak, describes what's happening in terms of the y. You see? So this notation is pretty compact and it describes behaviors on two different axes. Let's repeat this for the other side. But let me do that. Let me do something first here. I don't need this part of it, so let me erase that. Okay, I don't need this part of it either. It's gone. So look what's happening on this side now. All right, again, we need some kind of symbolism to express the fact that if x could be here, and then you're going to approach 2, and you're doing it from the left side. So x is here. Again, x stands for values. For example, since this is 2 and this is like 0 right here, maybe it's like 0.1, 0.5, 1.5, 1.6, 1.7, 1.8, 1.9. It stands for values that are getting closer to 2. That's why you need a variable, because you kind of are moving this way. So at least this part of it, the process here, could be described by saying x is approaching 2, but it's doing it from the left side. So up here you put a little negative to indicate you're coming from the left side. Then the question is, how do you marry this part with what's happening on the y-axis? I want to make sure everything is visible. So look, if x is right here, then look up to here, okay? It doesn't have to be perfect, it's the idea, of course, right? If x is here, then you look up to here. Now you are, so you're beginning here, then now you're here. If x is here, then look, you are in this position right here. So what's happening? As x goes this way towards 2 from the left, then the y coordinates, basically, or the points on the graph at first, if you like, are sliding down. Eventually, they're going to slide down to that same point right there on the graph. And look, when x is here, then the y coordinate is right here. When x is here, then the y coordinate is right here. When x is here, then the y coordinate is right here. So what are these y coordinates doing? As x gets closer this way, these y coordinates are going down in this direction right here. You see? They're approaching the same value of 0.8. They're just doing it from above. But nevertheless, it's the same value of 0.8 that I made up. So again, to express all of this in the right notation, let me do it over here. I would say the following. X is approaching, let's see, 2, and is doing it from the left side this time, like that. So again, this is describing what's happening on the x-axis alone. Then when you introduce this limit y, then this is describing what's happening on the vertical axis. And then you can say the limit of y as x approaches 2 from the left side is equal to 0.8, the same as for that example there. In this notation, right, 2 important pieces of information, one for the x-axis, and then basically like 1 for the y-axis with the 0.8, I suppose, included. And lastly, a bit of a new limit notation. What happens when you have this and when you have this? Right, this is 0.8 and the other one is also 0.8. They have the same values. Well, in that case, we take this and we take this and we marry them together into what we call the overall limit. So that can be written as the limit like this. And now look, x is just going to approach 2, and this 2 doesn't have a plus or minus up here, an exponent, and then you're going to say y. But nevertheless, so x is approaching 2. Now this notation says we've done it from both the right and the left. Okay, it's like the overall limit. This part is still the same. It's still going to describe what's happening along the y-axis. So the limit of y as x approaches 2 is equal still to 0.8. And again, we can say this because these individual limits, one from the left, right, and the other one up here from the right, those individual limits are equal, 0.8. So the overall limit without a plus or minus is the same, 0.8. And that's all I wanted to do in this video. I hope it's insightful and helpful. Please leave a like, please subscribe. Thank you so much for watching. Check out Kayla's related video on limits. It's on the channel. I'll put a link down below or in the cards. You can click on it. I'll see you in the next video.